Users saw 090001, too many connections, and the pipeline died. The Python connector wasn't pooling connections, and an unhandled exception in a loop left every new connection dangling. Snowflake provides native drivers and connectors for Python, JDBC, Kafka, Spark, Node.js, Go, and more. In this tutorial, you'll learn how to connect your applications to Snowflake securely and efficiently, with real code examples and a production incident that reveals a common pitfall. Drivers and connectors are software libraries that let applications written in various languages and platforms connect to Snowflake. Think of them as keys that unlock Snowflake's cloud data warehouse. Each connector has its own setup, but they all serve the same purpose: to connect your app directly to the Snowflake database, execute queries, and manage data. They are also key for data science, streaming, and big data. The Snowflake Python connector is the go-to for data scientists and ETL developers. You install it with pip, then create a connection using your account identifier and credentials. The connector supports both synchronous and asynchronous queries, returning a result set you can iterate through. Always use environment variables or a secrets manager for passwords, and you have an ideal solution for data science and ETL. Here's a basic example. Connect, execute a query, fetch results into a pandas data frame, then close the cursor and connection. In production, avoid hardcoding credentials and always close resources. The JDBC driver enables Java applications and BI tools like Tableau to connect to Snowflake. You add it as a Maven dependency, then use a JDBC URL with your account and credentials, and finally call driver manager getConnection to open the connection. This Java example connects using a properties object, runs a query, and prints results. Always close result set, statement, and connection. Set the query tag session parameter for monitoring. The Kafka connector ingests data from Kafka topics into Snowflake tables in near real time. It runs as a Kafka Connect sync connector and uses Snowpipe for efficient ingestion. Configuration is done via a JSON config file with support for Avro, JSON, and other formats. Here's a sample connector configuration. It maps the Kafka topic, orders topic, to the Snowflake table orders. Key settings include buffer count and flush time to balance latency and cost. Use key pair authentication for security. The Spark connector reads and writes between Spark data frames and Snowflake, optimized for large-scale batch processing. It supports both Scala and PySpark, making it flexible for your ETL and data science pipelines. Simply specify connection options, use format, Snowflake, and you're ready to go. This PySpark example reads from Snowflake using a SQL query. You can use option, DB table, orders to read a whole table. Set SF truncate to true for overwrite writes. Snowflake also provides a native Node.js Connector. Install it with npm, use create connection, and execute queries using callbacks or promises to retrieve result rows. It's lightweight, ideal for microservices. This Node.js example connects and runs a query. The callback pattern handles errors and results. Use connection pooling and environment variables for production. For production, avoid password authentication. Use key pair authentication. Generate an RSA key pair, assign the public key to your Snowflake user, and use the private key in your connector. This is more secure and supports automation. Here's how to use key pair authentication in Python. Load the private key using the cryptography library and pass it to the connect method. No password needed. Connection pooling is essential for production. It reuses connections instead of creating new ones for each request. The Python connector provides Snowflake connection pool for this purpose, and you can configure the pool size based on concurrency. Then, monitor with show sessions to ensure optimal usage. This example creates a pool of 5 connections. The with statement ensures the connection is returned to the pool after use. This prevents connection leaks and improves performance. The root cause: each ETL task created a new connection without pooling. When an exception occurred in the loop, the connection was never closed. Over time, connections accumulated until the warehouse hit its limit. For our ETL task, the fix started with implementing a Snowflake connection pool. Then we added try finally to ensure connections are closed, handle exceptions by setting abort detach query to kill orphan queries, monitor sessions via show sessions, return each connection to the pool, and keep everything healthy. Forgetting to close connections and cursors leads to resource leaks, as shown by the missing curclows and close. The fix is to explicitly close the cursor, then the connection, which releases resources promptly. Hardcoding passwords in code is a security risk. That's the before on the left. On the right, we fix it by calling os getenv snowflake password to pull the password from an environment variable, keeping credentials out of the source. The Kafka connector should use key pair authentication, not passwords. Storing a password in Snowflake password like this exposes credentials in config. Replace it with Snowflake private key to enforce key pair authentication and eliminate stored passwords. To debug connection issues, first test network connectivity by running curl v https://account snowflakecomputing.com, then verify your account URL and credentials. Use show sessions to see active connections and select system $kill session ID to kill idle ones. Let's review common interview questions about Snowflake connectors. Understanding key pair authentication, Kafka connector configuration, and Spark partitioning will help you in interviews. Let's recap frequently asked questions. The Python connector is for simple SQL, while Snowpark offers a data frame API. For Kafka, set up retries and a dead letter queue. The Spark connector works with Databricks. To sum up, select the right connector for your language and platform. Always use secure authentication, implement connection pooling, and monitor your connections using Snowflake system views and query tags. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.